Welcome to this tutorial, and in this video we are going to talk about the lung volumes and capacities. So we will briefly define all the lung volumes and all the capacities, and then look at one or two practical exam questions with regards to this very subtopic of respiratory physiology. Okay, let's delve into this. So these are the lung volumes that we have. These are the lung volumes that we have. Um, we have what we call tidal volume. Okay, we have what we call tidal volume. Um, so this tidal volume basically it is the amount of air that moves into the lungs with each inspiration, or the amount of air that moves out with each expiration. Okay, so usually tidal volume of a normal person is supposed to be 500 milliliter. 500 milliliter. And then we have um, we have expiratory reserve volume. Expiratory reserve volume. So this expiratory reserve volume is just the volume expelled by an active expiratory effort after passive expiration, and it is usually 1,200 milliliter, 1,200 milliliter. And then we have inspiratory reserve volume. Inspiratory reserve volume. So this inspiratory reserve volume is defined as the air inspired with a maximum inspiratory effort, and it is usually 3,000 milliliter. 3,000 milliliter. Okay. And then we also have residue residue volume. Okay, so residue volume, which is normally 1,200 as well. 1,200 as well. That is the value for residue volume. And then when we by definition, residue volume is just the volume of air remaining in the lungs after maximum exhalation. So by description, residue volume is just the amount of air that is left in the lungs after a person has exhaled as much as possible. Okay. So this volume of air is very significant when it comes to the maintenance of lung function, as it helps prevent lung collapse. That is residue volume. So these are the lung volumes. Okay, these are the lung volumes, and then now we have the lung capacities. We have the lung capacities. So when it comes to the lung capacities, we have inspiratory capacity. We have inspiratory capacity, which is defined as the maximum amount of air that can be inhaled after normal exhalation. And then we also have functional residue capacity. Functional residue capacity. Okay, we also have functional um, residue capacity. So this is just the volume of air remaining in the lungs after normal exhalation. After normal exhalation. And then we also have vital capacity. We also have vital capacity. So this vital capacity is basically the maximum amount of air that can be exhaled after maximum inhalation. Okay. And then we also have total lung capacity. We also have total lung capacity. Um, and this total total lung capacity, normally it is okay. So when we talk about total lung capacity, by definition, by definition, this is just this is just the maximum. Okay, this is just the maximum volume of air in the lungs after maximum inhalation. Okay, so in other words, total lung capacity basically represents the sum of all the lung volumes. Okay, the sum of all the lung volumes. Okay, so the normal values for total lung capacity in an adult male, it can range from 6 to 7 liters. Okay, and then in females it can range from 5 to 6 liters. Then in a child or in children, it can range from 2 to 4 liters. Okay, that is for total lung capacity. Now, having defined all the lung volumes, there is an easier way in which we can use to remember these lung volumes and capacities, either in an assessment or anywhere else. Let's see how we can remember this. Okay, so I will just use this blank page for illustration purposes. All right, so we can use what we can call as you can start by writing something like rate. Okay, rate, which is just R. Okay, so R, and then we can rate REIT. Okay, so rate like that. Okay, rate like that, and then we come to the R. So R, we just add a V, so that is your residue volume. When you come to the E, you just add RV. Okay, and then you come here, you just add RV as well. Then you come here, just add a V. Okay, so this is for starting. Okay, so you have your residue volume, you have the your ERV, you have your IRV. Okay, and then you have your TV, which is the tidal volume. So then from there, um you will notice that you need to take note that these these two. Okay, these two, these two components, actually they represent something. Okay, let me just use another color to differentiate. Okay, so those two, RV, which is residue volume, um, and the expiratory reserve volume, they represent something. And also these two, which are on the bottom, these two on the bottom like that, they are also representing something. Okay, and then we have when you look at when we get these three. Okay, when we get those three, they will also represent something. Okay, so now when we come here, you discover that we have basically the when we combine RV and ERV. Okay, when you combine RV and ERV, what we get is functional reserve capacity. Okay, and then when we combine inspiratory reserve volume and tidal volume, what we get is the IC. Okay, the inspiratory capacity. We get inspiratory capacity. And then when we combine ERV, IRV, and TV, what we get is the vital capacity, like that. Okay. And then when we combine all these, when we combine all that, what we get, what we get is total lung capacity. Okay, so basically this is a summary of all the lung volumes and the capacities. Okay, you just start with rate. So RV, ERV, IRV, TV, RV plus ERV, you get FRC. Then IRV plus TV, you get IC. Then ERV plus IRV plus TV, you get VC. And then all of these, when you combine them, you get TLC. Okay, so as simple as that. Now, having known how to come up with these calculating formulas, let's look at a question or two. We see how those values can help us. The question says a person has a vital capacity of 5 liters, a tidal volume of 0.5 liters, and an inspiratory capacity of 3.5 and a functional residue capacity of 2.5. What is his expiratory reserve volume? What is his expiratory reserve volume? So now, when you check on what you have been given, when you check at what you have been given, you've been given the VC, you've been given tidal volume, you have been given as well inspiratory capacity, you have also been given um, the FRC. Okay, so what you're supposed to find is ERV. ERV. Okay, that is what you are supposed to find. Okay, so now um, if we are to collect the data that we've been that we've been given in this question. Okay, we collect the data that we have been given in this question. Let's solve this question here. Okay, so usually usually you need to understand that from the table, from that illustration that we gave on how to remember the capacities and the lung volumes, we can deduce from that vital capacity is basically VC equals ERV plus IRV plus TV. Okay, and then we have IC being equal to IRV plus TV. Then we have FRC equals RV plus ERV. Okay, so these are what these are our formulas. Okay, and then when we look at the question that we've been given, when we look at the questions that we've been given, let's try to get some data. So this is for question one. Okay, we are solving question number one. Okay, so the data that we've been given so far, we've seen that we have the VC, and VC we've been given 5. Okay, let me just check to confirm. Okay, so VC we've been given 5 liters, and then we also have TV, of which we've been given 0.5 liters. Then we also have IC, which is 3.5 liters. And we also have FRC, which is 2.5. So that is our data right here. Okay, so these are the values that we've been given from question one. Okay, and when we check at the formulas that we have for us to find ERV, for us to find ERV, um, we need we need we need a formula which has ERV in it. Okay, so when you look at the first formula here, this one has ERV, but it requires us to also have IRV. And IRV on these values that have been given, IRV is not there. We only have VC and TV. Okay, then we come when we look at the last formula, we need RV. Okay, we need RV, and RV is not here. Okay, so the easiest way, and then when we look at the second formula, we have IC, IRV, and TV, and we have them here. So we are going to use the second formula to find IRV and replace it in the first formula, and then we get our ERV. Okay, so let's try to do that. We see. All right, so um, we're just replacing. We won't rewrite this formula again. Okay, so we are using this formula here. So what will happen is we know that IC we've been given 3.5. We've been given 3.5 and equals we have IRV which is not there. IRV like that plus TV which is 0.5. Okay, 0.5 like that. Okay, so when we continue with that, you'll find that according to mathematics, basic mathematics, we have IRV equals this this 0.5 will move to the other side, and you know that each sign will change from positive to negative. So you have 3.5. Okay, 3.5 minus 0.5, of which um, will give you IRV being 3.0. Okay, 3.0 liters like that. So we found IRV which is 3.0. Okay, now we can find ERV by just going back to this first formula. Okay, so even this one will just ex, replace the values. So you'll find that now we have IRV. Now we're just replacing. Okay, so what will happen here is that since we have the VC is just a 5, 5 equals ERV we don't have, okay, plus IRV we found it is 3.0 plus TV which is 0.5 like that. Then you know that you have your 5 there, you have your 5 right there, and then equals you have ERV. Then having added those two, I'm sure we are going to have 3.5. Okay, 3.5, and then you have ERV which will be equal to 5 subtracting 3.5, which will actually give you ERV of 1.5. Okay, will give you ERV of 1.5. So you have 1.5 when you press on your calculator liters. So basically that is how you solve um, this question. So this is our final answer. This is our final answer. So ERV is 1.5. When we go back to the question, we have 1.5. So that is in liters. This is in milliliters. So what you do is just you multiply with 1,000 and it will give you 1.5 milliliters. So this is our answer here. So you should take note that the standard, okay, so the standard um, ERV, we talked about it here, okay. ERV, we said it is 1.2, okay. So here we have 1.5, okay. All right, for a better understanding, let's look at another question as well. So question 2 says the following lung volumes are noted on spirometer of a 24-year-old physiotherapy student who has asthma. We have FRC. So here we've been given FRC. Okay, so you should be able to take note of the thing that you've been given. Okay, so you have FRC. You also have VC. Okay, apart from VC, you also have ERV. Okay, so these are the things that you've been given. Now the question is, you need to calculate the IC, the inspiratory capacity of this particular student. Okay, so we'll just use the same route. Um, we'll just erase. Okay, so looking at the data that we've been given, we've been given FRC to be 3.0 liters, and then we've also been given VC. Now this time around it is 6 liters, and these values are not there. Instead, we've been given ERV in this case, which is 1.5 liters, like that. So that is our data for this particular question. So how are we going to move about this question? So looking at the values that we have FRC. FRC is there. Then we have ERV, and then we are told to find IC. Now let's go back to this. We want to find IC, right? So remember, we've been given FRC. Okay, FRC is here, and then we also have VC. Okay, then we have IC. So they want us to find this one here. They want us to find IC. So what will happen here is we check. So VC comprises of IC. Okay, so VC is comprising IC including ERV. Okay, okay. Hopefully you are seeing that VC has IC and the ERV. So in this case, that is why we are saying that you need to know that particular way of remembering the formulas. So our formula, knowing very well that VC, okay, VC is equal to IC plus ERV, as simple as that. So what will happen is VC we've been given as 6.0, 6.0, and then IC, that is what we are looking for. Then we want ERV. I mean, we have ERV, of which we've been given as 1.5. Okay, like that. So what will happen here is IC, you have your basic mathematics knowledge, 6.0 minus 1.5, of which when you press on your calculator, you have IC will be 4.5, 4.5 liters. So this is our final answer. When we check on the solution, on the answer that we are given, 4.5 is here. Okay? So as simple as that. Thank you very much. Have a blessed day.